So the quadratic function, like I said last time, is a function of the form f of x equal ax squared plus bx plus c. Since this a is not equal 0, then I talk about how to graph the quadratic function by using the standard form. So any quadratic function, here any quadratic function, I can write it as a standard form, can be written of the form f of x. Here I can write it in the form f of x equal a times x minus h square plus k. Okay, so this is called the standard form. So any quadratic function like this, f of x equal ax squared plus bx plus c, I can write it as this form. This is review. Last time I gave example how we can find the standard form. This is called the standard form. So any quadratic function of this form, can I write it like this form? By this form, I can graph any quadratic function. Why? Because I can find the vertex, and like I said last time, the quadratic function is a parabola. This parabola like U shape like this. This is the graph of the quadratic function. It's open upward if this a is greater than 0. It's open downward if this a is less than 0. So I said last time, if a is greater than 0, this a I mean, so the parabola open upward. If a is smaller than 0, the parabola open downward. So the graph will be like something like that. Here the graph will be something like that. Okay, and also I said I can graph any quadratic function by using the standard form, this form, by finding the vertex. So the vertex of the parabola here, the vertex is the order pair of h comma k, h comma k. This h and this is k here. And also I talk about the minimum value and maximum value. So I said if a is greater than 0, so the parabola open upward, and then the function f of x has a minimum value. So f of x has a minimum value, and here if a is less than 0, so the parabola open downward. So f of x, the function f of x, has maximum value. And here the minimum value, I can find it as is f of x, f of h, this h equal k, and here has a maximum value. The value is f of h equal again k. So it depends in the sign of a. Okay. And I gave example how to find the standard form and all this stuff, the minimum and maximum value and the vertex. The last things I left from last time, I can find the maximum and minimum value without using the standard form, direct. So how can I find the maximum and minimum value direct? By this this rules. So here I can finding the maximum or minimum value from the quadratic function direct. So I can find the maximum or minimum value from the quadratic function direct without using the standard form. How can I find it? By these things. So suppose I have a quadratic function. Let my quadratic function like this. F of x equal ax square plus bx plus c, and a here not equal 0. So I have the maximum and minimum value at the point at x equal minus b over 2a. Now, if a, this a I mean, is positive, greater than 0, so this means the minimum, the function f of x, this one, has, if greater than 0, has minimum value. And the value for the minimum is f of this here, f of x, f of minus b over 2a. Now, if the value for a is smaller than 0, a is less than 0, so the function f of x has a maximum value. And the value is f of this point minus b over 2a. Now let me give you example, and we're going during the example explain how to find the maximum or minimum value direct by using these things. So here example, find the maximum or minimum value for f of x equal x squared plus 4x. So in this way, we don't have to find the standard form. I mean, for standard form, this things f of x equal a times these things. We don't have to find this to find the maximum and minimum value. So I can use these rules here to find the maximum and minimum value. So first of all, we have to check what's the value for a. Is it positive or is negative? So here, my a is, what is a here? What is a?
X squared.
It's going back here. F of x equal a times x squared. What's a?
1.
It's 1. So a is the coefficient for x squared, is 1. How find it? From here, because here we have 1 times x squared. So 1 is a. So now we have to ask yourself, is the 1 is greater than 0 or is less than 0? So a is equal 1, so 1 is actually is greater than 0, is positive number. This is mean if it's greater than 0, the function f of x has a minimum value. So the function f of x has minimum value. So what is the value? Is f of minus p over 2a. Now, what is minus p over 2a? So let me write it down here. Minus p over 2a is equal. So my b is this value. So actually, let me write it down again. So f of x supposed to be like a x squared plus bx plus c. So the coefficient for x squared is a, the coefficient of x is b, and c is the constant term or constant leading. So we don't have here constant leading is 0, actually is plus 0, but we don't have to write it down. So my function is f of x equal 1 x squared plus 4x. So my a is 1, my b is 4, is the coefficient for x. So here I get minus p is minus 4 over 2 times a is 1. So now it's the answer is minus 2 over 2, minus 4 over 2 is minus 2. So now here is equal f of minus 2. Now we have to plug the minus 2 inside the function. So when you plug the minus 2 inside this function, I get 1 times minus 2 squared from here plus 4 times minus 2. And the answer is 1 times minus 2 squared is 4. 1 times 4 is 4 plus 4 times minus 2 is minus 8.
So it's -4.
Yes. So here minus 8, and the answer is 4 minus 8 is -4. And this is my minimum value. Okay, any question? Any question? Sabrina, we don't have quiz today. Any question
Oh,
about
we
this?
do have a quiz today?
No, we don't.
Oh, okay.
Okay.
Would there be extra credit today?
Extra credit for what? Maybe.
Okay.
We'll see. Okay. About this example, any question? So it's easy to find the minimum value. Just you plug using this formula, this function. You plug the minus b over 2a inside the function, and this value is the minimum value. By why? Because a is 1, so the function has a minimum value. Okay. So by this example, we finished the section 3.1. Now let's go to the 3.2, is the polynomial graphs. So this is for only a quadratic function, any function of this form. Now we're going over the polynomial graphs. So what is the polynomial? Here, 3.2. Polynomial functions. And their graphs. So first of all, I have to define the polynomial function. So the polynomial function, like a polynomial equation, as we learned from chapter 1. So polynomial function of degree n is a function of the form b of x equal an x to the n plus an minus 1 x to the n minus 1 plus dot 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 plus a1 x plus a0. This is called here the coefficient. So here this is called the coefficient. This is called the leading term here. Leading term. And this is called the leading here. It's called the constant term. Also, an is called the leading coefficient. We're going to use it a lot during this section, leading coefficient. Okay. So this is my polynomial function. It's of this form. We have to know this is called the leading term. An only is called the leading coefficient. An here is called the constant term. Also, A0 is called the leading constant coefficient. So the leading constant term is the same as the constant coefficient. Okay. Also we have to know how to graph the basic polynomial function, like the basic, like this example here, graphing basic polynomial functions. This is just review from last times. We did that a lot in previous sections. For example, like graph the function like graph 1 b of x equal minus x cube, and also graph, this is example by the way, q of x equal x minus 2 everything squared. Okay, who will do the first one, or give me the idea how can we do the first one by using the transformation? What is the original graph here? What is the original function as we learned from before?
X squared.
No, this is x cube.
X cube.
X cube, yes. So like for the first one, I know how to graph the function O of x equal x cube. So the graph for x cube is something like this. This is from before. This is the graph of x cube. But the question is, the graph the function b of x equal minus x cube.
So it'll
What
be on the other side. Like that arrow will be on the other side since it's negative.
So reflected around which axis do you mean?
X-axis.
X-axis, exactly. So when the minus is outside, like here, this means we have to reflect the original function, like this one, around the x-axis. So my mirror would be like the x-axis, like this. And everything will be reflected around this axis. So the graph for b of x be like this. Here it goes up, and this side goes like this, down. And the green one is the graph of b of x. So this is b of x equal minus x cube. By the way, x cube is a polynomial function. Why? Because a n here is 1, and n the degree n is 3, and all the coefficient for a n minus 1 is 0. So this is a polynomial function. So the graph for the basic polynomial function is we reflected here for the first one, we reflect the original graph around the x-axis. Now for the second one, for the second one, how we can graph this one? What's the original function and what we did for the original graph? What is the original function for the second one?
It's x squared. It's a parabola, and it's shifted 2 units to the right.
Exactly, it's a parabola. It's x squared. Then here -2, this is mean it's inside. We have to shift the original function 2 units to the right. So the graph for the x squared, something like this, parabola, open upward, like that, but it goes down a little bit at 0, 0. So this is my original function, O of x equal x squared. This is O of x. Then we have to shift the original function 2 units to the right because we have x -2 and the -2 it's inside. This means we have to shift everything to the right 2 units. So here 0, 0 will be like 2 and 0 and everything to the right. So the graph will be something like this. And here like this. So this is the graph of q of x. This point is 2 and 0. Just 2. And here is the point is 0. And the same things for any polynomial function. So we have to know what's the basic or what's the original function. Then we can use the same rules as we learned from previous section is 2.6 transformation. The important things now we have to know is the graph of like by using the end behavior. So what's the end behavior? Here the end behavior. So suppose I have a polynomial function. Let my polynomial function is like this, b of x equal a n xn plus a n minus 1 xn minus 1 plus dot 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 plus a1x plus a0. This is my polynomial function. So to find the polynomial function, we have to know two things. The first thing, we have to determine the degree for the polynomial function. The second thing, we have to know what's the sign of the leading coefficient. So to find the end behavior, for any polynomial function, we need two things. The first one is the degree. Second thing is the leading term, the sign of the leading term. So here the degree n. What is the degree, by the way? What is the mean of degree? What is the mean of degree of polynomial? Like, for example, if I give you a polynomial.
Is it the highest level of exponent?
Yes, exactly. It's the highest power of the exponent. Like if my b of x equal, for example, 6x squared plus 3x to the power 4 plus 2x plus 0 plus 7. What is the degree here? So to find the degree here, we have to looking for the power for each term. So the power here, or the exponent, is 2. Here we have 4. Here we have 1. Here we have 0. So the highest exponent for this function is 4. This means the degree is 4 for this polynomial. So the degree is the highest exponent of the polynomial function. Okay. Second things we have to know is the sign is positive or negative for the leading coefficient an. So we need two things, the degree and the sign for an. So now I'm going to give you the rules how to find the end behavior. And by these rules, you can find any end behavior for any polynomial function. So first of all, suppose my b of x has odd degree. What is the odd numbers? The odd numbers like 1,
3.
3, 5, 7, all these are odds. 1, 3, 5, 7, 9, all of these are odd numbers. So suppose my b of x has odd degree, like the highest exponent is odd numbers, 3, 5, 7, 9. Now we have to check two things. If the leading here, this leading, is positive, if an is greater than 0, so the end behavior when x goes to infinity, you have to write it like this. When x goes to infinity, y goes to infinity. This is the rules. When x goes to minus infinity, so y goes to negative infinity. This is the end behavior for this one, the first case. And the graph for this one will be like similar to these things. Is not exactly, but similar to this. So when x goes to infinity, y goes to infinity, so it will be like that. And when x goes to minus infinity, y goes to minus infinity. So it will be like here, something like this, then goes down. So when x, the value for x goes to infinity, like the value for x become large, like this, become so large, the value for y become also infinity, goes to the positive infinity, so becomes so large too. Look, it goes up. Same things from the other way. When x goes to minus infinity from this side, the y goes to minus infinity. So this is the end behavior for the first case. For the second one, when an is negative, so the same thing's the end behavior. When x goes to infinity, y goes to negative infinity. When x goes to negative infinity, y goes to infinity. And here's the graph for this. So as we see here, when x goes to infinity, the y becomes so small, goes to minus infinity. And the same things for the other side. When x goes to minus infinity, this side, all the y becomes so large. So the y goes to infinity, positive infinity. This is when the b of x has odd degree. Now when the b of x has even degree, will be different. So now b of x has even degree. So what is the even degree? It's like 2, 4, 6, 8, and all these numbers are even. Same things. It has two cases. If an is greater than 0, so the end behavior when x goes to infinity and when x goes to minus infinity. So here the y goes to infinity, and also when x goes to minus infinity, the y goes to infinity. So the graph for these things, something like that. Like this. The end behavior when x goes to infinity, here it becomes large. The y goes to infinity, becomes so large. The same things for the other side. When x goes to small numbers, minus infinity, all the y's goes to infinity, becomes so large. This is for even degree, and the same things for when a of n is small. So the end behavior when x goes to infinity, when x goes to minus infinity. So when x goes to infinity, the y goes to minus infinity, and when x goes to minus infinity, y goes to minus infinity. How is the graph? It has something like this. So look, when x becomes so large, the y values become so small, goes to minus infinity. The same things here. When x becomes so small, the y values become so small, goes to minus infinity. Okay, any question? Anyone has a question about the end behavior? Okay, I'm going to give you example. And the example is find the end behavior. So example, find the end behavior for b of x equal minus 5x cubed plus 2x square plus 4x. Who will do this one? Like, can you start by give me what's the degree?
The degree is 3.
Is 3. And
And
what is the leading?
But then it's not -5, so it's negative. So at the end behavior, it's going to be y is going to be be very negative.
Okay, hold on. So perfect. This is nice. Degree and the leading. Now x goes to infinity, and the x
Y
goes to
minus infinity.
minus infinity. What is the y value?
Minus infinity goes to minus infinity.
Minus infinity. And what's the y value here?
Minus infinity.
Minus infinity. So when x goes to, so let's check. The degree is 3 and the leading is minus. Go back. So 3 here, odd. The 3 is odd. And the a of n is negative. So when x goes to infinity, y goes to minus infinity. When x goes to minus infinity, y goes to infinity positive. So here positive.
Oh, okay.
Yeah. And here negative. Just using the rules like before. So when x goes to infinity, y goes to minus infinity. When x goes to minus infinity, y goes to positive. How is the graph? The graph will be something like this. It's not the same exactly, but similar to this. Like that. Here, like something like graph like that, and then goes up. So look, when the value for x becomes so large, like that, the y value become minus infinity, so it goes down. When the x becomes so small, minus x, like that, the y becomes so large, goes up. So here, value goes up, become positive infinity. Okay, any question? Any question? Okay, let me give you another example. The example, find the end behavior find the end for f of x equal 2x plus 5x square plus minus 7x to the power 4 plus 2. So I need to tell me what's the degree and what's the leading. Leading what? Coefficient. What is the degree here? What is the highest power?
4,
The degree is 4.
It's 4. And what's the leading coefficient?
7.
Minus.
-7.
Negative
Is it-
7. The negative 7. So the degree is 4. The leading coefficient is negative 7. So now goes to the rules. The degree is even. Here is even. And the leading is less than 0. This is mean negative. Even and negative. So even and negative. So this means when x goes to infinity, y goes to minus infinity. When x goes to minus infinity, y goes to minus infinity. So this is the answer. When x goes to infinity, when x goes to minus infinity. So this y goes to minus infinity, and y again goes to minus infinity. So the graph will be something like this. Goes down, it goes up, like some stuff here. I don't know what is it, but then goes down. So again, when the function goes to infinity, positive, the y values goes to minus infinity. When the function goes to minus infinity, the y values goes to minus infinity. Any question? Anyone has a question? Is it clear? Okay, this is the end behavior. Now we have to know how to graph any polynomial function. So the end behavior will help me how to graph any polynomial function. So now let's go to the graphing the
Can you
polynomial.
go back?
Yeah, sure.
Thank you.
Mhm.
You can continue.
Okay. So now graphing a polynomial function. So to graph any polynomial function, we need only 4 things. First thing, we need to find the zeros. This is the first step. Second step, we have to test point. Third things, we have to find the end behavior. Last thing, we have to graph the function. I'm going to give you example. The question is the graph the polynomial function b of x equal x plus 2 times x minus 1 times x minus 3. Okay, so this is polynomial function. What is the degree for this polynomial function? If we multiply this parentheses,
It's the third. I mean,
3, exactly, yes. So if I multiply this parentheses, I will get the highest polynomial is 3. Why? Because here x times x times x, they give me x cubed. This is the highest degree for the polynomial. First of all, we have to find the zero. What is the zero for this polynomial?
-2, 1, and 3.
Yes, thank you. So To find the zero, like previous section, I said we're using this rules. If a, b equals 0, this means a equals 0 or b equals 0. So the same things here, we have a, b, c. If a, so this means a equals 0, like mean x plus 2 equals 0, then x equal minus 2, like Mobin said. The same thing is x plus 1 equals 0, then x equal 1, and x minus 3 equals 0, this means x equal 3. So the zeros, so the first one, the zeros are x equal minus 2 or x equal 1 or x equal 3. This is the first step. Second step, we have to find the test point and we have to graph the real line. So step number 2, we have to graph this line, the real line. So number 2, I have to graph the real line. And in this real line, I have to put this zeros, x equal minus 2, x minus 1 equal 1, and x equal 3 in this line. So here, this point is minus 2. This point is 1, for example. And this point here is 3. Again, my polynomial function is b of x equal x plus 3, x plus 2, and x minus 1 times x minus 3. Now we have to take numbers between these things and we have to test it, is the value is positive or is negative. Like, let me pick any number between 1 and 3. Which number would you like to pick here? Between 1 and 3.
2.
Let's take 2. Then you plug the 2 inside the polynomial and you check what is the sign you get. So b of 2, they give me 2 plus 2 is 4, and 2 minus 1 is 1, and 2 minus 3 is minus 1. The multiplication of this, 4 times 1 times minus 1 is minus 4. So the sign is negative. This means from 1 to 3 has a negative sign. This is the first one. For the second one, we have to pick any number is greater than 3. Let's take, for example, 4. And you plug the 4 inside the polynomial and you check what is the sign. So b of 4 equal 4 plus 2 is 6. 4 minus 1 is 3. 4 minus 3 is 1. So 6 times 3 is 18, times 1 is 18 plus. So the sign from 3 and above is positive. Now, what element would you like to pick from minus 2 and 1? Which number would you like to pick from -2 to 1?
Zero.
Let's take the 0. So b of 0 equal, you plug inside the function, polynomial function is 0 plus 2 is 2. 0 minus 1 is -1. And 0 minus 3 is -3. So the answer is 2 times -1 is -2 times -3 is 6, positive. So the sign here will be positive. Now pick any element less than -2, smaller than -2. Which number would you like to take?
-4.
-4. You plug it inside the function, b of 4, b of -4. I get -4 plus 2 is -2. -4 minus 1 is -5. And -4 minus 3 is -7. So 2 times 5 is 10. 10 times 7 is 70. And negative times negative is positive. Positive times negative is negative. So the sign here will be a negative. This is my second step, test the point. Third one is the end behavior. I'm going to do it here. So I said the degree, like Moben, she said, the degree for this one is 3. And the leading will be like x times x times x is x cubed, the leading is 1. Okay, after you multiply this parentheses, the leading will be 1. So this is odd. And the 1 is positive, greater than 0. So odd and greater than 0, odd, greater than 0. When x goes to infinity, y goes to infinity. X goes to minus infinity, y goes to minus infinity. So when x goes to infinity, y goes to infinity. When x goes to minus infinity, y goes to minus infinity. So now we are ready to graph the function, graph, the last one. So to graph that, first of all, we have to put this point, 3, 1, and -2. 3, this is -2, this is 1, and this is 3. So 3 and 1 and -2. The interval from greater than 3 is positive. This means the curve will be up of the x-axis. So the curve from 3 and above will be like this. Positive, because it's positive. From 1 to 3 is negative. So the curve will be something like that, under the x-axis, like this. Like this. Then from -2 to 1 is positive. This means above the x-axis. like this. Not nice. Like that. Then from -2 to minus infinity is negative, so down of the x-axis, something like that. And the end behavior are achieved because when x goes to infinity, y goes to infinity. Look, when x goes to infinity, y goes to infinity, positive. And the same things from the negative side, when x goes to minus infinity, y goes to minus infinity. Same things here, goes down. So this is my x-axis, and this is my y-axis. Any question for these things? Is it clear how to graph any polynomial function? Is it clear how to graph the polynomial function? Any question? Anyone has a question? Okay, let me give you another example. Example 2, graph. B of x equal x cubed minus 2x squared minus 3x. First step, we have to find the zeros. What is the zeros for this one? So we can factor it. What is the factor? What is the greatest common factor between the first and second and third term?
And x,
X. Then what's the remain?
x, I can't say.
Okay,
I can't say the degree.
we divide this one by x, we divide this one by x, we divide this one by x.
X minus 2x
2x
minus 3.
minus 3. Thanks. So now we can factor this parentheses again. What is the factor for the parentheses? So we're looking for two numbers. The multiplication is -3 and the sum is -2.
X minus 3
-3
plus 1.
plus 1. So -3 times 1 is -3 and the summation is -2. That's true. This is work. So now to find the zeros, I keep it like I put p of x equals 0. So now the zeros are x equals 0 or x here equal 3 or x equal -1. So this is the 3 zeros. Now we have to draw the line. This is second step, my real line, and I have to put the zeros in this real line and I have to check points. First zero is 0, -1, and 3. 3, 0, -1. Pick any element between 0 and 3. Which number would you like to choose between 0 and 3?
2.
2. Plug it inside the p of x here. P of 2 is 2 times 2 minus 3 is negative 1. 2 plus 1 is 3. So 3 times 2 is 6, times minus 1 is minus 6. So this is mean here we have negative. Negative, 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 negative. Now pick any element is greater than 3.
4.
4. Let's take 4. So p of 4 is 4 times 4 minus 3 is 1, and 4 plus 1 is 5. So the answer is 5 times 1 is 5 times 4 is 20. Positive. So positive. Pick any element between minus 1 and 0. Minus 1 half, right? Minus 1 half between minus 1 and 0. Block it inside this one. P of minus 1 half is minus 1 half, and minus 1 half minus 3 is minus, what is minus 1 half minus 3? Is minus 3 and a half, and here minus 1 half plus 1 is minus 1 half. Minus times minus is positive, times minus is negative. So this would be negative. So here we have negative. Now pick any element is less than minus 1.
2. Negative 2.
Negative 2. So here negative 2. Plug it. So p of negative 2 equal negative 2 negative 2 negative 5 3 is negative 5. Negative 2 plus 1 is negative 1. I get now 2 times 5 is 10, and negative times negative is positive, times negative is negative. Here we have some wrong. Negative 1 half plus 1 is positive. So here we have positive here. Negative times negative is positive, times positive is positive. This is positive here. This is greater than 0. So here we have positive. Now we have negative now here. So the interval will be here negative. Third step is find the end behavior. What is the degree for
3.
this? 3. And what's the leading?
1. No,
1
2.
is 1. So the degree is 3, and the leading is 1. If 3 is odd, and the 1 is greater than 0. Go back. Odd and positive, x goes to infinity, y goes to infinity, s goes to minus infinity, y goes to minus infinity. So when x goes to infinity and when x goes to minus infinity, y goes to infinity, y goes to minus infinity. Now graphing. So to graph, the first step, we put the zeros. The zeros come from here. -1 and 0 and 3. Now, greater than 3 is positive, above the x-axis. Between 0 and 3 is negative, down of the x-axis. So here negative. Then positive from -1 to 0, up to the x-axis. Then less than -1 is negative, down of the x-axis. Like this. So this is the graph of the function b of x. Any question? If you have a question, you can ask your question. No questions?
How is the leading one? I'm sorry, I missed that part.
Yeah, how to find the leading one. Okay. So the degree here is a 3. So the leading coefficient is 1, this one. This is the
So
leading.
whatever the highest degree is, that will always be the leading.
Yes, exactly.
I was just confused because the last one was like -7. That's all. So I thought this one would have been like a
Negative
3.
7. Hold on. Negative. Which? Yeah, this one. Okay. So the leading here is 4. The degree is 4. So the leading will be -7.
I got it now. I just thought of something else. That's all.
Yeah. So if the degree is 4, the leading will be in front of this coefficient, -7. Okay. Same things for all the examples. The leading is x times x times x is x cubed. So the leading will be 1. Okay. So this is what about 3.2, the polynomial graph. Now let's go to the new chapter 4.1, exponential function. Do you have any question from previous chapter? If you have, you can ask your question. So exponential functions. This section is smooth and easy. Review from high school. Talk about the exponential functions and stuff like this. So first of all, we have to define what is the meaning of exponential function. So the exponential function with base. So here I can define the exponential function as here. So the exponential functions with base a is a function of the form f of x equal is f of x equal a to the x. The base here is a. This is the base. This is called the base. So the exponential function is a function of this form, a to the power. This a here must be positive, a greater than 0. And also a not equal 1. Why a not equal 1? Why a here does not equal 1? Why f of x equal a and a here not equal 1? Second things here also x is a real number. So my question, why a not equal 1? So the exponential function is a function of this form of x equal a to the x, where a is positive, a not equal 1, and x, this one x, would be a real number. So how is the graph for the exponential function? So the graph, no, the graph for exponential function. So in general, the graph for the exponential function will be something like this. So the graph in general will be something like that. Here will be close to the x-axis, but they will not touch the x-axis. This means the x-axis here is a horizontal asymptote. Or the other graph of the function, the exponential function, will be something like this. This point is 1. And this point is 1 too.
Can you repeat the question?
So here again, the graph of the exponential function is something like this. The function will be like close to the x-axis, but they will not touch the x-axis. This line is called the horizontal asymptote, the x-axis. Here when a is greater than 1, the graph will be something like that. When the a, this a I mean, will be between 0 and 1, the graph will be something like this. The second things, like for example here, f of x equal 1/2 to the power x. This is example for this graph for this function, like because 1/2 is between 0 and 1. But about this one, f of x equal 5 to the x, the graph will be something like this. Second thing is we have to know the domain. The domain for the exponential function is always R. Look, all the values for the x are used. So the domain for the first graph for 1 and for 2 is always R, the real numbers. And the range is this. What is the range?
Infinity.
From where
0.
to, no, from 0 to the infinity. The 0 is not including. From 0 to
To
infinity is
yeah.
the range. The 0 not including because the graph will be like close to the x-axis, but they will not touch it at all. So the domain always R, the range always from 0 to infinity. Okay, second things we have to find how to find the question now. Find the exponential function. Any question for this? How to the domain about the range? Any question? Is it clear? So now my question is, my example is, find the exponential function. How to find the exponential function of x equal a to the x from the graph. So the graph like this, and the second one is like that. For the first one, the function has a graph like this. And it's passing this point. This point is 2, 25. The question is, find the exponential function. So I'm going to do this one, the first one. And for the second one, I keep it exercise. So the graph for the second one is like this. The graph passing the point 3, this point is 3, 1/2, 1/8. So for the first one, to find the graph, the function, so actually it's given the point 2 and 25. So the point 2 and 25, this is mean. F of 2 is 25. So my function is f of x equal a to the x, and it's given f of 2 is 25. F of 2 equal 25. And again, if I plug the 2 inside this function, f of 2, they give me a to the 5, a to the 2. My goal now is to find the value a. What is the value for a? So f of 2 is a to the 2, and this is equal 25. and the 25 is actually equal 5 to the 2. So my value for A is 5. So the answer for this example, f of x equal 5 to the x. What about the second one? Who will do the second one? Let me grab the second one in the other page. Next one, number 2. So the graph like this. The function passed the point 3 and 1/8. Any question before we're doing this? Before like I give you the hint for the second one. Here is it clear? Any question for this one? So actually using this point, you plug this point inside the function and you find the value for A. For here, so 3, they give me 1/8. So this means f of 3 is equal 1/8. And my function is f of x equal A to the x. So you plug the 3 inside this function, f of 3, they give me A to the 3. And this is actually equal to this one, equal 1 to the 8. And this one equal 1/2 to the 3. This means the value for A is the same like the value here, 1/2. So A equal 1/2. So my function now, f of x equal 1/2 to the x. Any question? Any question? Okay, I'm going to stop up to here today. And I see you next Thursday. Okay?
Professor, quick question. Are you going to
Yes.
curve the exam?
I'm going to talk about that next time, okay?
Okay, thank
Okay.
you.
Another question.
Don't forget about my extra point. Okay,
You-
thank you.
e-
Good night.
email me for this. Have a good night.